myself Ronil from grade 10. Albert Einstein once quoted that pure mathematics is in its own form a poetry of logical ideas. Today, through my presentation, we are going to explore one such logical idea, which is finding the number of tangents from a point to a circle. So let's begin. Before we move forward, let us understand what does a circle actually mean. A circle is a geometric 2D figure in which all the points on its edges are equidistant from one center point. Let us understand this statement with the help of this figure. In this figure, we are able to observe that all the points on the edge of the circle are equidistant from this one center point. It means the distance between any point of the circle on the edge of the circle with the center is going to be the same. Now, let us understand what does a tangent actually mean. A line which touches a circle at just one point is known as tangent. In the figure given below, the blue line is a tangent to the circle with center C. The tangent at the point of contact is perpendicular to the radius. It means that radius when connected to the tangent at point of contact will be perpendicular to the tangent. Now that we are aware of the definition of tangent, let us think how many tangents we can draw from a point to the circle. So, the number of tangents that we can draw from a given point to the circle depends on the location of that particular point. If that point is located outside the circle, exactly 2 tangents can be drawn from it to the circle. If that point is located on the circle, exactly 1 tangent can be drawn from it. And if the point is located inside the circle, we cannot draw any tangent from it to the circle. Now, let's prove these statements. Now, let me share an activity to demonstrate how many tangents from a point can be drawn to the circle. In this activity, the materials required are cardboard, geometry box, cutter, different colored sheets, and adhesives. So, now let's begin with the activity. Let me introduce you to the method of construction of this activity. First, we'll have to take a cardboard sheet of any suitable size and paste a colored paper sheet on it. Then, we'll have to take a colored sheet and draw a circle of any radius on it and cut the same. Then, we'll have to paste that cut out circle on the cardboard. Then, we'll have to repeat this step 4 and 5 thrice. In the first instance, we'll take a point P outside the circle and fix a nail on it. Then we'll take a string and tie one end of it to the point P and move the other end towards the center of the circle. Later, we'll move that string up and down. Then, in second time, we'll take a point P on the circle and fix a nail on it again. Again, we'll take the string and tie it to point P and move it up and down. And thrice, or in the third case, we'll take the point P inside the circle and fix a nail on it, and we'll repeat the same thing as we did in the previous 2 cases. Now, it's the time to record our observations. In this activity, we observed the following things. If the point P was taken outside the circle, we were able to draw 2 tangents from it to the circle. If the point P was taken on the circle, we were able to draw only 1 tangent from it. And if the point P was taken inside the circle, we weren't able to draw any tangent from it to the circle. Having performed this activity, let us have a look at the applications of this activity. After performing this activity, we were able to verify that if the point given is outside the circle, we are able to draw exactly 2 tangents from it to the circle. If the point given is on the circle, we are able to draw only 1 tangent from it to the circle. And if the point given is inside the circle, we aren't able to draw any tangent from it to the circle. Thank you very much.